Hello grade 10 math learners and welcome back to another video with me, Miss Martins. In today's video, we're going to be looking at trigonometry, exam questions, past paper practice. We'll be looking at the following questions. Please hit the subscribe button if you are not subscribed to my channel. As soon as you hit that button, you become one of my YouTube students and I can't wait to see you in more videos in the future. Let's jump right into this one. So it says 4.1. Given that 4 cot theta plus 3 equals 0 and theta is bigger than 0 but smaller than 180, use a sketch. Very important. You must draw a sketch. We want to see a sketch to determine the value of the following. Do not use a calculator. So we're not asking you to find the value of theta and then type in your calculator because of that angle. We don't want that. We don't want you to use a calculator. We want to see a sketch and we want you to use your sketch to find the value of the following. So first things first, how do we draw the sketch? So you need to know that the sketch will obviously take place on the Cartesian plane and we will be drawing the cast diagram. So all stations to Cape Town, cast diagram, C-A-S-T. I hope you know what these things stand for. This means that all of our ratios are positive. Our sin ratio is positive, tan is positive, and cos is positive. They give me the following information. So that and that. I'm going to take care of this information first. Theta is going to be bigger than 0, but less than 180. We know that this is 0, 90, 180, 270, and then back to 360. So if I tell you that theta is bigger than 0, but less than 180, it means that it is either in this quadrant or it is in this quadrant. It's not going to be in this one and it's not going to be in this one. Okay, so we figured out what the first piece of information means. Second piece of information says 4 cot theta plus 3 equals 0. That's not going to really help me with the form that it's in at the moment. So what I'm going to do is I'm going to get cot theta by itself. This is plus 3. Inverse of plus 3, minus 3. So take the plus 3 over, it becomes minus 3. That's step 1. This is multiply by 4. So it's going to be divide by 4. So what I've got now is that cot theta is equal to negative 3 over 4. But as you know, cot is one of my reciprocals. I'm not going to work with cot. I need to work with its reciprocal. Now, how I remember that this is the reciprocal, the third letter is T. So cot is the reciprocal of tan. So reciprocal of cot theta is tan theta. And remember, because it's a reciprocal, it means that we must flip this fraction over. 4 over negative 3. So what this is telling me is that my tan is negative. Okay, we got tan of theta is equal to negative 4 over 3. Negative. One of these values here is negative. So where is tan negative? Right, over here, tan is positive. So it can't be in that quadrant. Tan is positive also here because it's the T quadrant. So it can't be that quadrant. Tan is negative in this quadrant and it's negative in this quadrant. Now, which quadrant has 2 tick marks? This one over here, which means that it is in this second quadrant that my diagram must go, that my radial arm must go. Okay, so we use the first piece of information to get the black tick marks that you see. Then we use the second piece of information, which gave me the purple tick marks. And clearly, here's a tick mark here, but there's also a cross here, so it can't go here. Here's a tick mark, but here's a cross, so it can't go here. Here's 2 tick marks, so that is where the arm is going to go, like that. So essentially, we're looking for this theta over here. What we need to do, as soon as we found which quadrant our arm goes in, we always attach the arm to the x-axis to create a triangle. So there's the x-axis, ground it to the x-axis, creating a 90-degree triangle. The angle, the reference angle that I'm going to be working with, is always inside the triangle between one of the sides of the triangle and the x-axis. So this is the angle over here. Now what we know is the following bits of information. Tan theta is equal to negative 4 over 3. Tan, as you should know, is equal to opposite over adjacent. That means that opposite theta is going to be 4. And I hope it makes sense that the 4 will be positive because, and I know a lot of my students get confused about this, why would tan be, or why would 4 be positive? Because 4 is this y value over here. And if you think about this, the y values on this side, all of the y values here are positive. So you go like 0, +1, +2, +3, +4. So this would have to be a positive. The y values down here are negative, but we're not talking about down here. We're talking about up here. Okay, so that's where the +4 comes from. And then this over here is adjacent. The adjacent value is 3. But it is -3. There, -3. And again, it makes sense for it to be negative because it's on the left-hand side here of my x-axis. These are negative x values here. These would be positive x values, but I don't care about that. So that would be negative x values. That is why it is very important to get this in its standard form. Again, remember tan is opposite over adjacent. That's how I knew opposite my angle. Opposite my angle was the 4. Over there, and adjacent to my angle was the -3 over there. So that's how you figure out your sketch, which yes, we do want to see in your paper. And now we're going to answer the questions. My first one is I have to find the value of cos theta. Now, cos, as you should know, is equal to adjacent over hypotenuse. So cos is adjacent over hypotenuse. Here's my theta. What is adjacent to my theta? -3. What is the hypotenuse of this triangle? We don't know the hypotenuse, but what can I do in order to find the hypotenuse? I hope you're saying Pythagoras. If you are correct. So the hypotenuse is equal to, hypotenuse squared is equal to 4 squared plus -3 squared. We're looking for alongside. We add them, we square them. Ultimately, h is equal to 5, Pythagoras. Therefore, the hypotenuse is 5, and that is your answer. Cos theta is -3 over 5. That's how easy it is. We actually generally, just by the way, in this sketch, we generally call the hypotenuse r. So this would be r over here. This is r, and r will always be positive. Just by the way, keep that in mind. So my hypotenuse, my r is 5. It is my hypotenuse, +5. Got it from Pythagoras. Done. The next expression that I need to find the value of is 3 sin theta sec theta divided by tan theta. Okay, so 3 multiplied by, so we're going to say 3 multiplied by, now sin theta. Let's make my diagram a bit bigger. Theta is over here. I need to work out sin or sine theta. Sin or sine is opposite. What's opposite theta? 4. +4. It's positive because the y value is going this way, are positive. So 4 over hypotenuse 5. Remember, sin is opposite over hypotenuse. So we've got 4 over 5, like that. 4 over 5. Then new bracket for sec theta. So let me just color code so that you know what I'm doing. Sin theta is 4 over 5. Sec theta. Sec is a reciprocal of one of my 3 well-known trig ratios. Look at the third one, the third letter. So remember cot, the third letter tells me it's the reciprocal of tan. Sec, the third letter, tells me it's the reciprocal of cos. Okay, so reciprocal means we flip the fraction. So it's the reciprocal of cos. Now, what would cos be? Cos would be adjacent over hypotenuse. So what is adjacent to my angle? -3, and my hypotenuse is 5. So if this is cos, then sec would be the reverse or the reciprocal of that. 5 over -3. And then tan, looking at my angle, tan is opposite, so 4 over adjacent, -3. So I have substituted. Now I have to simplify this. Okay, so what I did is I simplified it without the use of a calculator. So I first multiplied the green fraction with the yellow fraction, and then I multiplied 3 with 20 to get 60 divided by -15, and then I divided the last 2 fractions, and my ultimate answer is 3. Technically, when they say without the use of a calculator, what they mean is that they don't want you to use a calculator to get these brackets. So out of the 4 marks that this question is out of, you get 1, 2, 3 marks for substituting into the fraction without using your calculator, but by using your diagram, and then you get 1 mark for your answer. So you definitely can type this stuff into your calculator to get your answer, but I'm just showing all my steps. My next question says, hence, show that sine squared theta minus 1 equals negative cos squared theta. Now, when a question says hence, it means that you must use previously worked out answers or previously constructed diagrams like this one in order to answer this question. Basically, what this question wants me to do is they want me to show that this left-hand side of this equation is equal to this right-hand side of the equation. So if I break it down, I'm going to do a little squiggle line like this. If I break it down and I work out what sine squared theta minus 1 is equal to by using the diagram, and then what negative cos squared theta is equal to using the diagram, if those two sides are equal, then I've shown that that equation is true. So I'm going to use the diagram to show that and work this out, and then show that they're the same. So how would you do sine squared theta? I hope you know that sine squared theta is basically sine theta squared, okay, minus 1. We spoke earlier about what sine theta was. Remember, it is opposite. So 4 over hypotenuse 5 minus 1. Now, 4 over 5 squared. What is 4 over 5 times 4 over 5? That is 16 over 25 minus 1, which is negative 9 over 25. Okay, check your calculator, type it on your calculator to see that I've done that correctly. I definitely know I have though. Then negative cos squared theta. Okay, negative, then it's cos theta squared. That's what that means. Okay, so negative cos is adjacent, so negative 3 over hypotenuse, which is 5, and we're going to square it. Now, just be careful here, because cos squared theta, it is the cos theta that we are squaring, not the negative. So the negative stays outside the bracket. Negative 3 over 5 squared, so it's negative 3 over 5 times negative 3 over 5. This negative gets carried down, and basically what we're doing is this. I hope that makes sense to those of you that are doing this with me or are following me. This negative again gets carried down. Negative 3 times negative 3 is positive 9. 5 times 5, positive 25. Therefore, we have shown that sine squared theta minus 1 is equal to negative cos squared theta. And then we can conclude that at the end. So I would therefore say negative 9 over 25 is equal to negative 9 over 25, or you could even say left-hand side is equal to right-hand side. Therefore, sine squared theta minus 1 is equal to negative cos squared theta. In 4.2, I'm simplifying the following expression without using a calculator. Now, when they say without using a calculator and you see the following angles, 30, 45, and 60, you know you need to use special angles and what we call your special triangle, which look like this. You need to memorize these triangles and you need to draw them on your page when we ask you this in the exam. Please make sure you memorize your triangle correctly. I recently marked my grade 10 papers and my students would sometimes swap these around and then they get the entire thing wrong because they've memorized their triangle incorrectly. Okay, cool. Now what you do is you say cos 30, look at the triangle where you see 30 and you do cos of 30. So what is cos? Cos is adjacent over hypotenuse. So what is adjacent to 30? Square root 3. What is the hypotenuse of this triangle? 2. Okay, so cos 30 is square root 3 over 2. So instead of cos 30, that's what you put down. Then tan of 60. Go to 60 in your triangle. What is tan? Tan is opposite. What's opposite the 60? What side is opposite the 60? Square root 3. What's adjacent to the 60? 1. Square root 3 over 1. That is what tan 60 is. Then we have got what it says here, cosec squared 45. Okay, cool. Cosec is again a reciprocal. The third letter, S. So cosec is the reciprocal of sin. Now, 45. 45, look for 45 in the triangle. It's not in this top triangle over here, so it's going to be this bottom triangle. It doesn't matter which 45. 45. Cosec, reciprocal is sin. So let's look for sin 45 first of all. What is sin 45? Sin is opposite, so square root 1, sorry. Opposite over hypotenuse. Hypotenuse is square root 2. So if this is sin 45, cosec, the reciprocal, will be the reciprocal of this. So square root 2 over 1. So basically you flip it. So square root 2 over 1. But take note how it was cosec squared 45, which means that we must square this fraction. Okay, so cosec squared 45, that means cosec 45 squared. Cosec 45 times cosec 45. Cosec 45 is the reciprocal of sin 45. So find sin 45 and then flip the fraction. And then our last one is multiplied. So we're going to, this is a plus, so we must put a plus there. Then this is multiplied by sin squared 60. So again, that is sin 60 squared. So again, we're going to have something in here and we're going to square it because of that squared over there. So 60, sin is opposite, so square root 3 over hypotenuse 2. Now it says without using a calculator. So we need to do this properly, do order of operations properly without using a calculator to us. You can use a calculator to check if you're right. So first we are going to multiply these two together. Square root 3 times square root 3 is 3. If you have a square root times a square root, the square roots cancel basically. And then we've got, so that's top of fraction. What I've done is numerator times numerator, square root 3 times square root 3 is 3, and then 2 times 1 is 2. Okay, so we multiplied the first two together, got me 3 over 2. Then I'm going to say plus. Then I'm going to square this. Again, basically what squaring means is that times that. Square root 2 times square root 2 is 2. 1 times 1 is 1. Okay, so all I've done now is I have squared this term to get me this one over here. Then I'm going to do the same thing with this one. I'm going to square that term. So it's square root 3 over 2 times square root 3 over 2. Square root of 3 times square root of 3 is 3. 2 times 2 is 4. Okay, cool. Now what I'm going to do is I'm going to multiply these two together. Again, top times top. So it's 3 over 2. Top times top is 6. 1 times 4 is 4. Now technically without using calculators we have to get them over the same LCD. So I'm going to write this one over 4. You times the bottom by 2. You times the top by 2. So it's 6 over 4 plus 6 over 4, which is 12 over 4, which is 3. I really hope that that made sense. That was quite a lot. But basically break it down, do BODMAS, do each piece by piece, and then you'll get to your final answer. Right, my last question says solve for theta correct to 2 decimal places. So we've got 4 over 3 sin theta equals cos 37. Now, cos 37 actually has a value. If you type that in onto your calculator, you will get a value. You actually get 0.798635551. So that's actually got a value. It's 0.79 ... We want to solve for my angle. So we need to get the angle by itself. We need to get sin theta by itself. It is currently being multiplied by 4 over 3. So we need to do inverse operations. This is like a normal equation. What is the opposite of times 4 over 3? Yes, divide by 4 over 3. So we need to divide both sides by 4 over 3. That will get rid of 4 over 3 on the left-hand side. So cos 37 divided by 4 over 3. and you should get this really long answer that we're not rounding off yet. We get 0,5989766, so on. We still haven't gotten theta by itself. When we are looking for theta, so we got sin theta. When we want to get theta by itself, that's when we need to shift sin. So we shift sin and type in whatever's on the right-hand side. Shift sin, whatever's on the right-hand side, that whole long number, and we get theta is equal to 36,7966. That is basically 36,8 degrees. I really hope that this past paper has helped you. I know it didn't cover the entire part of trig, but this was the trig asked in this particular past paper. Let me know if you want to see more trig past paper questions. I do have more. Just check out the links below. But if you want to see even more, comment down below. Can't wait to see you in another video very soon, everyone. Bye.